Evaluating limits analytically means simply you have a function, and how do you evaluate the limit? It's not a graph, it's not a table. For example, limit x approaches to 5, 3x minus 2 divided by x plus 5. All you need to do simply is, the first step is to substitute the limiting value. If you substitute the limiting value, if it is a regular number, and that would be your answer. So for example here, if I plug in 5 into this, that's a 13 over 10, and that would be your answer. Sometimes we may have indeterminate formats. Indeterminate formats, for now, I want you to learn few indeterminate formats, then we will learn more later. 0 over 0, infinity over infinity, infinity times 0, 1 plus 0 to the power of infinity. These are the indeterminate formats. Okay. So if we have indeterminate formats, how would you calculate this? So this is a little chart. I made it for you. You may want to take the good notes of this. You have to write everything down. Be careful. Analytical limits. The first step is you substitute the numbers. If it's not indeterminate, in the sense if it's not one of these formats, when I plug in, then you just plug in. That's it. If it's indeterminate, then you have to follow one of these things. For example, if it's a rational function, then factor and cancel. I don't know if you can read this. It says cancel. Factor and cancel. We will see each one of them in today's lesson. Make sure you focus. Second method is radicals. That means if you have square roots or cube roots something, rationalize it. Fractions like 1 over x plus 3 minus 1 over x divided by 2 over x, something like that, crazy fractions. Then take common denominator. Higher order powers like x to the 4 minus 3 to the power of 4 over x minus 3. We have few formulas to use. You will use those formulas. Then we will do piecewise functions. That's the fifth method. We'll go back to sixth one. Complex powers like 3x plus 2 to the power of fourth power, or even second power minus 2 squared, something like that. Then expand it. Then we will do limit at infinity. So limit x approaches to infinity, x to the power of n, or x cubed plus 3x over 2x minus 4x cubed plus 7, something like that. Then we will write trig limits. How do you find if the limit of a function involving trig? And finally, we will look at the absolute value functions. We will do each one of them individually here. Let's take one example of each. But these are the methods that I want you to remember. Make sure you take good notes of it. So first one is a rational function. So for example, if you have limit x approaches to 3, x squared minus 9 divided by x squared minus 7x plus 12. So again, remember, the first step is always what? Plug in. Never forget that. If I plug in, I get what? 3 squared minus 9 divided by 3 squared minus 7 times 3 plus 12, I get 0 over 0. So because it is indeterminate, I cannot write that as the answer. I cannot write this as the answer. You can't write that. So it is a rational function. I need to factor. So what is the factoring of top? The difference of squares. You have to memorize this formula. If you forget, that is x squared minus 3 squared. So I factor this to be x plus 3 and x minus 3. In the bottom, regular factoring, you have to find two numbers that add up, that multiply to 12 and add to 7. So I take x and x. What two numbers multiply to 12 and give you 7? Negative 3, negative 4. And see if we can cancel any of those. X minus 3 cancels out. Then I will be left with this. Plug in. Now that would be your answer. Second method, function involving radicals. Say for example, I have limit x approaches to 3. Did we take 3 before? Let's take 4. Limit x approaches to 4, square root of x plus 5 minus 3 divided by x minus 4. Again, you always follow the first step, which is substituting numbers in. You get square root of 9 minus 3 over 4 minus 4. That's 0 over 0, indeterminate. So I have to follow one of the methods that I wrote. And here, if you go back up and look at it, the method says that if you ever have a function that involves radicals, if you want to evaluate the limit and it's indeterminate, then make sure you rationalize. So far, you have a misconception that rationalization is only for the denominator. It doesn't matter, numerator or denominator. Excuse me. It doesn't matter if it is a numerator or denominator. The only thing that we need to worry about is there is a radical and I'm getting indeterminate, so I need to rationalize. The rationalizing factor of this is square root of x plus 5 plus 3, and you need to multiply the same thing on the top and bottom to balance the equation. And you need to be careful where you simplify it. This is the problem. That's why I got the rationalizing factor. So I'm going to distribute these two. But I am not going to distribute these two. I will keep them same. If you start distributing these two, FOIL or whatever you call, then you will have a problem. Again, I have a problematic term on the top, so I only distribute it to the top, not to the bottom. Again, I want you to recall the formula. The difference of squares is that these two terms adding and subtracting, that's like a minus b, a plus b. So if I use that formula instead of distributing, I can get a squared, which is square root of x plus 5 squared, minus b squared, which is 3 squared, divided by, I am not distributing these, I will just bring them down. When I simplify this, I get x plus 5 minus 9 divided by x minus 4 square root of x plus 5 plus 3. Combine like terms on the top. I get to cancel some of the terms here so that I can get rid of that indeterminate format. Plug in 4 into the leftover function. Then I get 1 over 6. That's my answer. Third kind of functions, solving analytical limits, that we are going to deal here is the function involving fractions. We have fractions here. I'm going to plug in 1 over 1 minus 1 over 1 over negative 1 plus 1, that's a 0 over 0. You must always check this. It has to be indeterminate in order to follow one of those. Because it's indeterminate and there are fractions involved in it, I will take common denominator. If you remember a common denominator, you need to multiply these two. There is no common factor to it. So my least common denominator is this. I need to multiply first fraction by 2x plus 3 because I need to match the denominator. And the second one by x plus 2 to match the denominator. That's what's missing there. First one, 2x plus 3, is missing when I compare. In the second fraction, x plus 2 is missing when I compare. So I multiply those numerators respectively. On the first one, I get 2x plus 3 minus, because there is a negative sign, I'm going to keep parentheses to the next one. And I also have x plus 1. Combine like terms and distribute them. I get 2x plus 3 minus x minus 2 divided by x plus 2, 2x plus 3. Instead of writing this denominator over here, I always like to write it like that so that I don't have to deal with fraction over fraction. But it's your preference what you want to write. Combining like terms over there, I get this. Then, can we cancel anything here? Good. Then the leftover is always 1 on the top, because nothing is there means that's 1. And you plug in negative 1 into the leftover function. Why am I started plugging in here instead of margins? Because I'm confident that one of the terms canceled out, then I'm not going to have indeterminate format anymore. If I get indeterminate format here again, I would follow the same method that I did before.